Hello, welcome to day 6, the last day of unit 6. We're going to do tangent and normal lines again. If you remember, the way we write linear equations is the point slope form, and if we use our calculus, we have the derivative is the slope part, and plugging in x into the function is my y part. So I need 3 things again. 1, 2, 3. And the first thing I need is a given x value. You will have to be given some x value, and then you will have to be given a function. And to find the y value, you just plug that number into the function. And then again, we would need a slope. And we take the derivative, and we plug that given x value into the derivative, and we find the slope. Example. Very easy, we've done this before. So f of 3 is equal to 3 squared is equal to 9. So I have the point 3 comma 9. My derivative of this function is 2x. I plug the x value in there and I get 6. This is my slope. And my tangent line is y equals 6, x minus 3 plus 9. And my normal line is y equals negative 1/6. Opposite and reciprocal for normal means perpendicular. X minus 3 plus 9. So what does this mean? Well, I've showed you this before. If this is the graph of x squared, and here on this graph is the point 3, 9. This is my tangent line, which looks like it has a slope of 6, pretty steep. And this is my normal line, because they should be perpendicular to each other, and it looks like it has a slope of negative 1/6. Okay. Right now we're just starting off with explicit equations. So again, normal tangent line. I have these guys, so f of negative 2 will equal 5 times negative 2 squared minus 2 times negative 2 plus 1. And when I do all that, I get f of negative 2 is equal to, I get 24 and 1, I get 25. Negative 2, 25 is my point. I take the derivative of this function. I get 10x minus 2. I plug in negative 2. I get 10 times negative 2 minus 2. F prime of negative 2 is equal to negative 22. I can write my tangent line. Y equals negative 22, x plus 2 plus 25, and my normal line is y equals 1 over 22, x plus 2 plus 25. Okay, not so bad. And then my last example here, I have x equals 1, so f of 1 equals 2e 3 to the first, which is going to be just 2e to the third. Okay. So my point is going to be 1, 2e to the third. I don't care what 2e to the third is, just some number. My derivative is going to be 6e to the 3x. So I plug in my value, I get 6e 3 to the times 1. And f prime of 1 is equal to 6e to the third. That's my slope. So my tangent line is y equals 6e to the third, x minus 1 plus 2e to the third. And my normal line is y equals negative 1 over 6 e to the third, x minus 1 plus 2 e to the third. Okay? You don't have to simplify things or do this and that. You can just leave it in the point slope form. So these first three examples were examples where we have very explicit function equations that we've been doing for the last month, 6 weeks, and writing normal and tangent lines. So how are we going to do this when we have implicit functions? Well, I'm still writing my same equation, y equals mx minus x1 plus y1, and except sometimes with implicit equation, wow, I already have both x1 and y1 given to me. The difference though now is that this slope is my derivative. I need my dy over dx, or my y prime, whatever you want to call it. So here's my function. X squared plus y squared is equal to 25. I'm taking its derivative. And we did this function the other class, or something basic. You like it. I get 2x plus 2y. Oh, there's a y. dy dx goes with it. Is equal to the derivative of 25 is 0. Now I can go two ways. One way to do this is to solve for dy dx like we did yesterday. So I bring the 2x over. 2y is equal to 2y dy over dx is equal to negative 2x. I divide by 2y, and I get dy over dx is equal to negative x over y. And that is my general derivative. And if I want to know what it is when I use the point negative 3, 4, I get my dy over dx is equal to 3/4. And that will be my slope. But I'm not going to do that a lot. A lot of times what I'm going to do, and this one was an easy one, so it wasn't so hard. I'm going to take this. This is my implicit differentiation. And here I can plug in the points negative 3 and 4 for all the x's and y's, and can make my life a whole lot easier because I don't have to deal with all these variables. Again, this example didn't have a lot going on. It was pretty easy to solve for the general derivative of dy over dx. But if I could do this here, I would get negative 6 plus 8 dy over dx is equal to 0. I add the 6. I get 8 dy over dx is equal to 6. And I divide by 8. And guess what? I get the same result I had before. dy over dx is equal to 3/4. Except it was a whole lot algebra. It was a lot less algebra than before. So my tangent line is going to be y equals slope of 3/4, x plus 3 plus 4, and my normal line will be y equals negative 4/3, opposite and reciprocal, x plus 3 plus 4. So even though I can solve for dy and dx like I did yesterday, finding the implicit derivative, after I start it, I'm going to plug into my x and y. It seems to go a lot quicker, and I have a lot less algebraic manipulation that I have to do. So let's do this problem. Like I said, what I like a lot of times, I give you both the x and the y. I don't have to figure out the y value, but I do have to take this derivative. X squared plus xy plus y squared is equal to 7. And I'm taking its derivative of this whole thing, and I do notice that in the middle of the problem, I've got a product rule. So I'm going to put this off to the side. X becomes 1, y becomes 1. I'm going to use y prime this time. So I'm going to take its derivative, x squared is just 2x, plus, oh, this product rule case is going to be 1y, plus, now I go the other way, 1xy prime, plus the derivative of y squared is 2y, oh, there's a y there, got to times another y prime, is equal to the derivative of 7 is 0. Now I could plug in 1, 2 for the x's and y's. When I do that, 2 times 1 is 2, plus y is 2, plus y, x is 1, so 1y prime, plus 2 times 2 is going to be 4y prime is equal to 0. Now you have 4 plus 5y prime is equal to 0. 5y prime is equal to negative 4, or y prime, which is my dy dx, is equal to negative 4 over 5, and there's my slope. I have a tangent line, y equals negative 4 over 5, x minus 1 plus 2, and I have a normal line, y equals 5 over 4, x minus 1 plus 2. So you notice how when I plug these numbers in, I get this equation here, and I don't have a lot of variables left. I only have y primes left. I think it makes life a little bit easier than rearranging like we did yesterday. That took some work. Finally, I have this guy. I have 3x squared y plus 5xy third minus 2y to the fourth is equal to 20. And I'm going to take its derivative, the d dx of all this. I notice I have 2 product rules. So I'm going to put these off to the side. I have a 3x squared, 6x, I have a y, 1y prime, and I have my other product rule is 5x, 5, y cubed, 3y squared times a y prime. Every time you do a y, you got to put in an extra y prime. So I'm going to have a product rule here, I'm going to have a product rule here, and this one is no product rule. It comes out nice. So my first crisscross, 6xy plus 3x squared y prime is the first one, plus now I get the other one, 5y cubed, plus multiply those coefficients, I get 15 x y squared y prime. That's what I get when I crisscross, and then I have to do this one, which is going to be minus 8y to the third. Don't forget there's a y there, so I have to do times y prime equals, and the derivative of 20 is 0. Now I'm going to plug in 2, 1 for all the x's and y's, and when I do that, 6 times 2 times 1 is going to be 12. 2 squared is 4, times 3 is 12y prime, plus 1. 1 cubed is 1, times 5 is 5, plus 15 times 2 is 30, and 1 squared is 30y prime, minus y to the third is 8, or 1 times 8 is 8, y prime is equal to 0. I can combine some things, and I see I got 17 plus 34y prime is equal to 0. Well, that actually turns out pretty nice because I have 30y y prime. Excuse me. 34y prime is equal to negative 17. So my dy over dx, or my y prime, is equal to negative 1/2. If I had to rearrange all those letters to solve for y prime, I could. It's going to be a little bit messier with all that algebra involved. That's why I like plugging in my x and y's right after I take the implicit differentiation. So when I have my tangent line, I get y equals -1/2, x minus 2 plus 1, and my normal line is y equals, well, it'll be 2, x minus 2 plus 1. Okay, I think today's a little bit easier than yesterday. Ask questions.